During a baseball practice, two players hit baseballs at the same time. Brett's ball is given by this model, and Andre's ball is given by this model. So we're going to start by completing the table. So let's start with Brett's ball. So I'm going to type in negative 16x squared plus 79x plus 6. And I'm going to graph it. Now I need to adjust the window so I can see everything. So I need to be able to see the top. I don't need to have all these negative numbers. Let's go up to 50 and see if that is high enough. Not quite high enough, and I still have some extra here. So let's take out some of that. Let's go negative 2 to positive 8. And let's try up to 100. Very close. You can still have a little bit more room at the top to see things. And I also want to have some more room in the bottom here, so that when I determine the zeros, I can see at the bottom what the numbers are. So, first part is maximum height. Second, trace maximum. Left bound, right bound, and guess. Remember, the maximum height is a y value, so y equals 103.5. Feet above the ground. Now the air time, that means when does it hit the ground? So what is our zero, our x-intercept, our real root? Those are all interchangeable terms. So left bound is above, right bound is below, and guess is back to that point. This is a zero, by the way. This is scientific notation for zero rounds too. So 5.01. So 5.01 seconds. Rate of change from 0 to 2. Remember, there's 0 and, there's 0 and there's 2. So 0 goes with a value of 6 and 2 goes with a value of 100. So y2 minus y1 over x2 minus x1. 100 subtract 6 over 2 minus 0. That's 94 divided by 2. 94 divided by 2 means that the average rate of change over the interval from 0 to 2 is 47 feet per second that it rises. Okay, let's do the same thing with Andre's baseball. Second plus 712. So we're going to plug in the negative 15.72 x squared plus 66.45x plus 5. Okay, again, I can get rid of this extra. Let's try negative 2 to 8, and let's go up to 80 and see if 80. I'm just taking a random guess. Okay, I need a little extra room up here, a little extra room down here. So let's go up to 100, but let's give ourselves space so we can see the x-intercepts. Second, trace maximum. Left bound, right bound, center. The maximum value is 75 point, whether you write 2 or 0.22, really up to you because it doesn't state what it wants you to round to. So either would be, oh, it says to the nearest hundredth. It says to the nearest hundredth. I need to go back to make sure that this is rounded to the nearest hundredth. Okay, let's go to the next one. Time in the air. I need to find out what is this 0. Second, trace 0. This was, I put it down, this was 0.52 feet. Okay, so I'm going to come down here and above it, below it, and back to it. And this would be 4.30 seconds. And now let's figure out the average rate of change over the given interval. So 0 goes with 5, and 2 goes with 75.02. Y sub 2 subtract y sub 1 over x sub 2 subtract x sub 1. 75.02 subtract 5 divided by 2 subtract 0 is 35.01 feet per second. So they both are going upwards, and that makes sense because the baseball is being hit into the air. One goes up faster, one's in the air longer, one has a higher maximum height. So let's now look at the next questions based on this. Whose ball reached the highest point? And that would be Brett's ball. Okay, here's our proof. Brett's ball reaches a higher maximum height. Whose ball hit the ground first? So whose ball was in the air for less time? That would be Andre's ball. Whose ball travels faster over the given interval? So this rises at a greater rate, and that would be Brett.